All right, so for now, we're going to restrict at this point our conversation specifically to dealing with data from populations. We're going to talk about how to do all the stuff I'm going to go through now for populations, and then we'll double back for samples. So this is the second way of measuring variability. The first was range. The second one is variance, and this is version A of it for populations. We'll have a 2B when we do samples. So that's sort of the organizational strategy I'm using here. For this section, what I really mainly need you to do is just follow the logic of what I'm explaining to you. Don't worry about the math of what I'm explaining to you, because right now in this video, I'm not showing you how to do the math. It's close to a way that's shown in the book, but I don't want you to do what I'm doing. I'm trying to express to you the idea of what we're trying to get done. Okay? So in doing that, just try to follow the logic of what I'm accomplishing. I'm also forewarning you right now, I'm going to deliberately lead us into a trap. I'm going to walk us right into a dead-end alley that we're going to have to figure out how to get out of. My purpose for this is to try to show you why we do things the way we need to do them. So, we're going to lay out our objective, our mission statement, if you will, and it's going to take us a while to figure out how to get to it. But here's what we're going to try to get to. We're going to try to figure out what the average distance is of raw scores from their mean. So we've got a set of scores, right? Our data for our population. And we're going to say, what's the mean of those scores? The central tendency, what's the center of them? And then we're going to say, well, how far from that central point are the scores on average? Imagine we were sitting in a classroom together. Okay, so you guys are all in your seats and I'm up here at the front of the room and I pull out a tape measurer. And I'm going to stand in the middle of the room and I'm going to measure. How far is that student from me? So the tape measure comes out and they are that many inches from me. And the next student is, 48 inches from me. And the next student is 52 inches from me. And so I'm representing the center of the room. I'm representing the center pillar, if you will, the mean. And I say, well, how far is this student from me? How far is that student from me? How far is the other student from me? How far is the other student from me? And I get the measure of all their distances from me. And then I can just get the average of that. Well, on average, students are sitting this many inches from me. That's what we want to do in our data. That is our mission statement that we want to get to. So how do we get that to happen? So the first thing we're going to need is some data to work with. So let me just put up some simple data here. So it's a small population. It's a population of 5 people. That's all that's in it. And conveniently, 1 score each. One person got a 1, second person got a 2, so on and so forth. So just 5 scores here. Now again, what am I wanting? I want to know, on average, how far away are these scores from the mean? So what's the first thing I'm going to need to know? I'm going to need to know the mean. So for this data, I need to get the population mean. So 5 plus 4 plus 3 plus 2 plus 1 divided by 5, we know this from chapter 3, is 3. So the mean is 3. That's that central pole. And now we want to know, how far is this score from the mean? How far is that score from the mean? How far is the other score from the mean? So on and so forth. And average them. These distances are called deviation scores. By the way, I know I put a word up here I haven't talked about yet. I haven't talked about it on purpose. Don't worry about it. I'll get to it. So these are called deviation scores. This is an idea that will come up in a couple of chapters. They'll have different sorts of names, but it's the same idea. Deviation score is the distance between a raw score and the mean. So the deviation score is simply calculated by taking the raw score and subtracting from it the mean. Make sure you subtract in this order. Don't flip those symbols around. So it should not be mean minus raw score. It's raw score minus mean. A deviation score gives you 2 bits of information when you've calculated it. Just a simple subtraction tells you 2 things. The first thing it tells you is, well, how many points away is it? Again, thinking of variability as distance. How far? It's this many points away. It's that many points away. And then the result will also either be positive or negative. If it's positive, that tells you the raw score is above the mean. And if it's negative, it tells you that raw score is lower than the mean. So that's why we have to make sure we subtract it in the correct order, or the positives and negatives will be reversed, essentially. So let's go ahead and figure those out. So make a column for our deviation scores. So 5 minus 3 is 2. 4 minus 3 is 1. 3 minus 3 is 0. 2 minus 3 is negative 1. 1 minus 3 is negative 2. We now have our deviation scores. We've computed them. I've taken my tape measure and said, how far is this? How far is that? How far is this? So here's the central point, and this score is 2 points away, this score is 1 point away, so on and so forth. So now we said, if we were doing this with our distance example in the classroom, now that I have all the distances, we simply are going to average them up, get the mean of these deviation scores. So why don't you go ahead and do that? Go ahead and pause it for a second, the video, and compute the mean of your deviation scores. 2 plus 1 plus 0 plus negative 1 plus negative 2 divided by 5. And what you should see is that the mean of these deviation scores is 0. Well, hold on, let's think about that for a second. We just said that this score is 2 points away from the mean, and this score is 1 point away from the mean, and same thing on the other side, 2 points away and 1 point away. How can it be then that on average, the raw scores are identical to the mean? We can see that clearly isn't true. This answer doesn't make any sense. Remember I said I was going to walk you into a dead end? Here it is. This is the trap. This is why we can't do it this way. The sum of deviation scores will always equal 0. It doesn't matter what the raw scores were. It doesn't matter what the mean is. When you calculate the deviation scores and add them up, the sum of deviation scores is always 0. Remember that our central tendency, the mean, is in the middle of the data, which means that roughly half the values are above it and roughly half the values are below it. Positives and negatives cancel each other out, so it always ends up as 0. 0 divided by anything is still going to be 0. So if we tried to do it this way, what we end up with is the same answer and the wrong answer every single time. That we have the sum of deviation scores equaling 0. 0 divided by 5 is 0. That doesn't make any sense. So we have to fix it. We have to somehow get out of this dead end. Well, what could we do to all the numbers as a constant that would get rid of these positives and negatives? There's a few things, but the one we're going to do is square them. Remember that if you square a negative number, it becomes positive. So what we're going to do is square these deviation scores. Again, this looks similar to a procedure in the text. I don't want you to follow this procedure. I'm just trying to get you to understand what we're trying to do, not how to do it. This is not how we want to do it, but this is just having us try to understand the concept. So we square our deviation scores. 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared is 1, negative 2 squared is 4. Now we've gotten rid of the negatives, everything's positive. Now we really can add these things together and average them. So 4 plus 1 plus 0 plus 1 plus 4 is 10. 10 divided by 5. So the mean of these things is 2. So let's take a look at something here. We got the deviation scores, and then we got the squared deviation scores. And in order to compute that mean, we had to sum them. So the sum, and then let me write that a little differently than the others. The sum of these squared deviation scores was 10, so that the mean of those turns out to be 2. That word is important, that's why I'm really hitting it. The sum of squared deviation scores is 10 points. And so the average of these squared deviation scores is 2. So let's pause right there. We need to start a fresh video clip. We're at the end of the time on this one, but we're going to pick up right from here. Okay? See you in a second.